Okay, let's continue with our simplifying. We're going to do just a few examples down here. We can multiply radicals and we can add and subtract radicals. Adding and subtracting radicals is very similar to collecting like terms when you're adding and subtracting polynomials or just terms. Multiplying radicals is not too challenging once you get the hang of it. So let's look at this one first. Multiplying radicals, you look at the coefficient part and your coefficients get multiplied together. And then you look at the radical part and you multiply the radicals together. So it's really similar to multiplying variables or terms. So let's look at this first example. I've got 3 root 3 times 4 root 3. My coefficients are 3 and 4. And my radical parts are root 3 and root 3. So we're going to multiply root 3 and root 3. And we're going to multiply 3 and 4. Okay, so let's do this on this side. Okay. So 3 root 3 times 4 root 3. Okay. My coefficients 3 times 4 get multiplied. That gives us 12. And then 3 times 3 get multiplied, and that would give us root 9. Now, in this example, we can continue. In this example, we can continue to simplify. So the square root of 9 is 3. So when we keep reducing or keep simplifying, this becomes, instead of 12 root 9, it becomes 12 times 3, which is 36. Okay, so we can simplify this guy over here to become 36. Okay. All right, let's look at the second one. Okay, 3 root 5 times 4 root 3. The 3 and the 4 get multiplied together to give us 12. And then the root 5 and the root 3 get multiplied together to give us root 15. We can't simplify this anymore. So you are finished. There's no way you can break up 15 to take a root evenly. So we're finished. Okay. All right, let's look at, there we go. Let's look now at adding and subtracting radicals. Adding and subtracting, you can only add and subtract radicals that have the same radical portion. So in this first one right here in example A, we are looking at 4 root 3 minus 2 root 3. Because they both have the same root 3, we can just take the 4 minus the 2, right? So it's like having variables, right? Like 4x minus 2x should give you 2x. Here, 4 root 3 minus 2 root 3 should just give us 2 root 3. Okay. Part B, root 8 plus 2 root 8. That would be like having 1 root 8 plus 2 root 8, right? Just because there's no number in front, you can treat it as though it's a coefficient of 1. 1 plus 2 is 3. And we end up with 3 root 8, okay? What do we do if the radical part is different? Let's take a look at, this one. Can I do that in my head? Actually, let's do this one first and then we'll go over there in a second. Okay, so let's look at part C. 3 root 32 minus 4 root 32. Sorry, 4 root 2. Okay. This does not have the same radical portion as this, so I need to simplify or reduce this radical. So 32, if I think about 32, I can take 32 and multiply it by 6, break it into the factors of 6 times 2. (16 times 2, I'm sorry. Now, root 16 times 2, I can't take the root of 2, but I can take the root of 16. So I'm going to take the square root of 16 to give me 4. So this is going to be 3 times 4 root 2, and then minus 4 root 2. Okay, 3 times 4 is 12. So I'm left with 12 root 2 minus 4 root 2. And now since the radical portions are the same, I can subtract the coefficients. So 12 minus 4 is 8. And I just keep my root 2 parts. So 12 root 2 minus 4 root 2, I should be left with 8 root 2. Okay, let's do one more example.
So easy. This is so much easier.
Okay, let's do one more example. I wanted to do part D, the cubed root of 16 plus 5 times the cubed root of 54. So I'm going to try and write all of this one down. I hope we can fit it. So this is the cubed root of 16 plus 5 times the cubed root of 54. Okay? Now, we can take the square root of 16, but not the cubed root. Remember, cubed would mean something times something times something. So these ones are going to be a little bit tricky. So what I can do is I can take 16 and I can break it up into 8 times 2. Okay. Now, the reason I would want to do that is because I can take the cubed root of 8. Okay. It will give me, the cubed root of 8 is actually 2. So this will give me 2 times the cubed root of 2. Okay, and then we can add this part here. So now I've got 5 times the cubed root of 54. But I'm going to break 54 up into 27 times 2. Now, why do I want to look at 27 times 2? 2 reasons. I knew that I was going to have root 2, and if I take 54 divided by 2, I get 27. This is good because can you think of a number multiplied by itself 3 times that gives you 27? I can. It's the number 3. 3 times 3 times 3 is 27. So I can take the cubed root of 27 to give me 3, right? So I'm carrying down the 5. The cubed root of 27 is 3. And then I am left with the cubed root of 2. And now that my radical parts are the same of this term and this term, I can add my coefficient parts. Let's just simplify this first. 5 times 3 is 15. Okay, and 15 plus 2 gives me 17. So this is 17 times the cubed root of 2. Okay, so we can work with square roots, cubed roots, all sorts of roots. Okay. All right, that is pretty much it. I mean, we can use them to multiply and use our distributive property over here. We can FOIL, where you take the 3 and multiply by everything. Okay, there's a few examples in your book that you can take a look at. Good luck, and all of your questions are posted on your table of contents, which are on D2L. Okay, good luck, guys, and we'll see you for the next session.